Okay, so let's get started with this class. So I hope my screen is visible. Yes, so welcome to week 6 of the Joy of Computing Using Python course. So this week we'll be looking at some problems on recursion, and we'll also be doing one question on like cipher. So there were some lectures on, I think, substitution cipher. So I have a problem which is like a step ahead of that, which is called like Caesar cipher, if you may have heard. We'll get to that. So we'll get started with some basic recursion problems, and then next week I think we'll do some more advanced recursion. So okay, so about this class, anytime if you have questions, feel free to unmute yourself and ask questions, or you can also write them in the chat. But yeah, just feel free to unmute yourself because I may not look at the chat always. And okay. But yeah, so I'll be showing some questions. It will be good if you also, even if you don't code it out yourself immediately right now, it will be good if you can actually at least try to, try to solve them yourself. At least get so that you get some idea about the questions. So okay, so first question is a very simple one. So this is called. So basically, you just have to calculate, say, x to the power n, the power of x. So this is a very simple question. Just think about it for 2 minutes, then I'll start solving. Let me see once if my camera is visible. No, nothing is visible, but okay. Okay, let's carry on. So okay, just so write a recursive function to calculate x to the power n. So we'll be solving this. So we'll be doing it both ways. We'll first try to do it in an iterative way, and then so for all of these questions, in general for recursion, most of the recursive, not most, all of any recursive function can also be written without recursion in an iterative, like using loops, for loops, while loops. But yeah, in some cases using recursion is easier. Like you can do it both ways, but using recursion makes it a lot easier in some cases, whereas in some cases using iteration is makes it easier. So let's do it one by one. Okay, let's see. Okay, so this is a very easy question. So suppose we have to do calculate x to the power n. So if you want to just do it in a loop, we'll do, say, take input. I'll not take input, I'll just set some value, say x05 and n equals to 4. And if you need to calculate the power, then we just need to store variables. Say, let's call it just let's call it p. So we are initially setting it to say 1, and then we have to do a for I in range. So some basic stuff. For I in range n, you have to do p equals to x, then print p. So this is very straightforward. We are just multiplying x to p n times. Alright, and let's just test out the answer once and see that it's okay. So yeah, it gives us 625, so nothing fancy in this. So now what about the recursive function? Using recursion. So suppose so using recursion, we always have to create a function. So let's make that function. Let's call it define as power. Let's not call it power because pow is like our inbuilt default function. So let's call it power, and then we have an x and we have an n. So we want to calculate x to the power n, right? So if we just use loops, this would be our function. Just set it and then return p. So this is our function, and then here we would have to do return power x comma n. So this will give us the same results. Yes. So this is our power function. So now we want to convert it to recursive function. So our recursive function is basically a function that calls itself somehow. Okay. And if you have watched the lectures, so a recursive function has two parts, you can say. So one of them is like the base case, and one part is the recursive case basically. Let's comment it out and we'll write side by side, and you can see that it's quite similar to what we are going to do. So here we have to understand what is the base case basically. So when should we stop calling this function, or when should we stop the iteration basically. So here we can see that we are running this loop basically n times, or you can we could have done it in another format also. If you would have also done it like in reverse, say this range is calculating say 0 to n, so we could have also done it n to 0 times. So our base case will be basically when n is less than equals to 1. So we know what is the power of something x, x to the power 1 or x to the power 0. We know that let's just do equals to 0. Okay, so we know that the power of like anything to the power 0 is 1. So this is the base case, so we know that we have to return 1, right? So if we whatever x be, if x to the like we are doing to the power 0, then it is 1. So this is our base case, and we are setting if n equals to 0, then return 1. And now the other thing is the recursive case, which is the fun part obviously. So let's just write it in 2 lines first. So something and then return p. So how do we get power? So power, we know that power is like basically we want to do x to the power n. We'll just use this fact that x to the power n is basically x into x to the power basically n minus 1. So this is our recursive formula, you can say. So x to the power n is x into x to the power n minus 1. So we'll just use this, and then it becomes just straightforward. So we'll do x into, and then this part can be written as power of x to the power n minus 1. So we can just do it power of x n minus 1, sorry, n minus 1. So this is basically just our recursive case, and we don't need a variable to store it. We can just return directly. And now you can see that so we initially also we had like few lines only 3-4 lines, but now also you can see that we have just 3 lines only, and this will basically do the same thing. If we run it, we are still getting the right answer. So to understand what is happening, we can take a look at the variables and understand what is happening. So I'll just write in the comments here. I'll try to explain what is going on, why like what is this whole thing doing. So basically when we are calling with say print power x comma n, basically we are printing this. So what is happening is we are calling this function with x 5 and n is 4. So initially, so now we are coming into this function and we are getting called, like we want the answer to power 5 comma 4, right? So the power 5 comma 4, then we are going inside the function and we are checking, is n equals to 0? No, n is 4, so we don't go here. So we are doing what we are returning. We are returning x into power of this, right? So this is equal to basically 5 into power of 5 comma 3. Okay, so now we are calling this function again. So now we want the answer to power of 5 comma 3. So we are calling this function again basically. So power of 5 comma 3, we want to calculate this. So when we are calling this function again, we are going inside the function and we are checking if n equals to 0. No, because n equals to 3. Then we are again returning this. So we are returning basically 5 into power of 5 comma 2, because n minus 1 is 2. So again we need to calculate this. We are calling this function again basically. So we again will go into another function, power 5 comma 2 2. Again to calculate, we again check if n equals to 0, no, and we go on. So this time we return, so I'm speeding up a bit. So we return power 5 comma 1, and again we call this function power 5 comma 1. So power 5 comma 1. Again we check the condition, n not equals to 0 because n equals to 1. Again we return 5 into power of 5 comma 0. Okay, so this time now something different will happen. So now we want this answer, so we are calling this function again, obviously 5 comma 0. So now inside the function, this if condition comes true, so now n is actually equals to 0. So instead of going to the second part, we'll just return 1. So we know that this is equals to 1, right? So we are not calling power function again. So we know that this is 1. So now this value will get returned to this here. This 1 will come and be substituted in place of this 5 comma 0. So basically this will become 5 into 1. Okay. So now we know that 5 into 1 is 5. So now we have also calculated the value of 5 comma 1. So this part is over. So we'll send this value back to this function. Now this will get replaced with 5. And so again we can calculate now 5 into 5 is 25. And so now we have calculated the value of this, no more calling. So we'll return this value over here again. So this will become 25, similarly, which is 125. And then again this value will get substituted here, 125, which is equals to 625. And that is our answer. Then finally this power is returning 625. And that is the value that is coming to print over here, and we are printing it. So that is how our recursive function basically works. Are there any doubts? So this is our very simple example. Any doubts on how the recursion is working? Otherwise we'll go to the next question. We check the chat. Okay. Okay, my face is half visible now, but okay. Yes, so let's go to the next question. So this is also not a very difficult question, a straightforward question. So just write a function to remove all vowels from a string. So if you are given some input like this, A, B, C, D, E, F, you want to remove the vowels, say A and E, and you want to print the remaining. So this kind of program you have already written with loops, I think in week 2 or 3, I think 3 or 4 maybe. But okay, so now we want to do this with the help of a recursive function. Okay, so what we want to do is basically remove all vowels from a string. Okay, and okay, so let's take an input. So let's call it S is A, B, C, D, E, F. Okay, so now what we want to do is remove this. So again, let's start with a normal function using loops, and then we'll quickly convert it. So this time I'll go a bit more quickly because it's almost the same thing. So let's create a function called say rem vowel, and we'll S, and it returns another thing, and then finally we'll print rem vowel, rem vowel S. Okay, so now what do we do in this function? Basically we have to go over so we can do it in multiple ways, but let's do it in a way that will make us that will be helpful in converting this to a recursive function. So let's make another temporary string. Let's call it say tmp, an empty string, and we'll be adding characters from the string to tmp. So first obviously we have to go through all of the characters in S, and we have to check if ch is a vowel basically. So that is So to check it, we do yeah, A E I O U. So I hope you know what in does. Like in a if statement, in is basically checks if ch is there inside this string. You can also use a list. So if character is there in this, then we basically don't do anything. And if it is not there, then we add the character to the string, basically ch. So as simple as that. And then we finally we return the TMP. So obviously this part is does not make sense. So the better way is that if ch is not in vowels, like if character is not a vowel, then we add it to TMP. Let's test it out. Okay, so we can see the answer is BCDF, so that is our desired answer. Okay, so how can we convert this to recursive function? So in a recursive function, obviously you have to understand two things. So firstly, we have to understand what is the base case and what is the recursive case. So the recursive case is basically you have to identify what is a recursion here. So you can understand one recursion here is that we are taking a character and we are checking it, and then we are doing if the character is present in this is a vowel, then we are basically like not doing anything, and if it is not a vowel, then we are adding it to the string, and then we are basically doing the same thing for the rest of the string. So we can say that in a recursive case we can say check current character and then do necessary stuff, and then you can do check the remaining string. So this is basically your recursive case. So we can call this basically we can call this function on say s1 like after the first character, right? And it will do the same thing. So to convert it to a recursive function, and obviously the base case you can understand is if the string is empty, if there is nothing to check, no more characters, then you just return that this is an empty string, so nothing to check, so just return an empty string. And also you can see that the base case is kind of like similar to what like our initial default case, right? So in here the base case for our recursion would be if s equals to empty string, then we just return we can return s, we can return empty, both will do the same thing because s is empty. And yeah, now coming to the recursive case, what we have to do is we have to check, okay, here we need some more 2 lines basically we need. So we need to check if character, let's say ch equals to string, the first character of the string, right? So we are taking the first character of the string inside ch, and we are checking if it is a vowel or not. If ch is let's say in a e I o u, so if it is a vowel, then we don't add anything, we just return whatever whatever string we can get by in the rest of the string. So let's do it. Remove vowel s 1. So this is basically we are telling that so if the first character is, we are taking the first character inside ch, if the first character is a vowel, then we don't do anything, just return whatever whatever we are getting after removing the vowel from the rest of the string. And if it is a like not a vowel, then what we do, then we just return this current character plus remove rem vowel s1. So that's it, that's our code. So here also we are doing basically the same thing, we are checking if it's an empty string, then we are just returning. If it is a vowel, then we are not adding that character, basically we are just returning the rest of the string after removing the vowels. And if it is not a vowel, then we are returning this current character, and then we are doing the rest, like we are removing vowels from the rest of the string and returning it. So let's check it quickly. So we are still getting the correct answer. We can check with say something else, and yeah, so I has also been removed. So So yeah, so another relatively easy code. So any questions with this? If there are any questions, you can ask. Else we'll move on to the next question. Let me check the chat once. Okay. Okay, then let's move on to the next question. Slightly more challenging, but still not a very difficult thing to do once if you have understood the previous ones. So here we are like this is almost the same as the previous question, but there is a slight trick. So a small trick you have to do. So we have to just write a recursive function to reverse a list. So given say 1 2 3 4 5, we want to return a list which is 5 4 3 2 1. So simple question. Answer is also simple, not very difficult. Let's get to it. So yeah, let me just put this to the side. So program to reverse a list using recursion. Okay. Yeah, so again let's just copy paste the last program. Let's do it from first only. Okay. Define so let's call it rev list, and we'll take a list as input and we'll do something, and let's take an input, say L1 equals to say 1 2 3 4 5. Let's print rev list L1, right? So this should give us the correct answer. So now one thing is, obviously in Python reversing a list is quite easy. So if you just do say L colon colon minus 1, so this means start from the beginning, go till the end, and like go in negative steps. So this is basically what you need to do to reverse a list in Python. But here we want to do it using recursion, because yeah, even though obviously in the real world if you want to reverse a list you will not use recursion, but we are doing this to understand the concepts of recursion basically, so that we can solve more complex problems later on. So yeah, so let's reverse a list using recursion. So yeah, again here also you have to identify the base case and the recursive case. So I think from the previous example, I think you can understand what is the base case here would be. So the base case would be basically when the list is empty. So if the list is empty, then there is nothing to do. So len list equals to 0, return an empty list, or you can also return L, because L is an empty list itself. So this is what we are returning. So this is the base case basically, right? Okay, one more thing, a quick side note, a quick trick. So if you have in Python specifically, if you have to check if a list or a string is empty, then you don't need to do this. You can just do basically if not L. So this just means that if the list is empty. Okay. So this is a shortcut you can say in Python. You can do with strings also. So in the previous program, like we used this, you can also use over here, say if not S. So this just means that if S is empty. Alright, so coming back to this program. So if the list is empty, then we just return the empty list, right? And so if the list is not empty, then we have to think about the recursive case. So so what can the recursive case will be? So here also we have to do like last time only. Last time also we took the first element, we did something, and then we called the other function, right? So here if we do say like item I, or item, let's call it item equals to L0, and say if, okay, here we don't have any if condition, we just have like only one thing returned. So let's do like last time. So last time we did say item plus rev list L. Okay, so what will this give? So if we run it, we'll see that the list has not been reversed. Oh, okay, base case. Oh, okay, sorry. Okay, so yeah, so we have to like the last program. So we are doing after the first element, right? Okay. Oh, int and okay, so this is a list item, so we have to do something like this. So this is how you add two lists, basically join two lists basically. So yeah, you can see that they have not been reversed because we have just picked up the first item and then basically kept it the same as like in the same order. So this is what we did in the last problem, but here since we want to reverse, there's only a very small thing we need to modify. Can anyone guess what we need to change? It's a very simple change. Anyone can unmute your mic and say? Oh, power has come back. So I hope my face is visible now. Okay. Yeah. So any ideas on what we need to change?
Sir, index will be -1. Item is equal to L of -1.
Sorry, can you repeat?
Index. Hence index will be -1.
So you're telling here index -1, something like this?
Yeah, on the top. Item is equal to L of -1.
Yes. Yes, so that is one way of doing things. Yes. So you can actually
Yes.
start with the end of the list. So this basically means we are basically starting with the last element and we are
Yeah.
basically going till the last element. So yes. So this is a very simple change. And yeah, so the other way to do it is, so can you unmute yourself again? Sorry, can you mute yourself again? So the other way to do it is, especially if you don't know the end of the list. So in Python, this won't be a problem. It won't be a big problem if you do it this way. But if you like, the other way to do it is basically you take the first element, like keep everything as it was. What you just need to do is just put this item at the end. So you just add this at the end, and this will give us the same results. So basically, instead of adding the current item at the end, we are adding it at the instead of adding the current item at the start, we are adding the current item at the end. So this is also doing the same thing. I'll not do the whole computation, but I'll show it quickly. So initially we had like say 1, 2, 3, 4, 5. So from here we are say basically taking out the first. So we are saying it like first element plus 2, 3, 4, 5, reverse of 2, 3, 4, 5. Then so let's just do for like say 3 only. Let's just do till here only. 2 plus say 3, and then like so this plus means like list, addition of list, not numerical. Then 3 plus empty. So empty list, we already have the answer. So this is our base case when it's an empty list. So we want to add it to the end, right? So we are adding, instead of adding it to the start, we are adding to the end. So this will become basically so let's, I wrote it in a different way, sorry. So plus 1 plus 2 plus 3. So this is our basically our recursive cases. So this is what we are doing. We are adding stuff at the end, right? So this will become the answer to this will become 3. So this will not change, basically it will stay the same. Then we're adding 2 to it, so 2. So this now has become reversed, and now we are adding 1 to it, and so this will become the reverse. So this is how we reverse a list using recursion. Okay, so let's now move on to slightly more so this is also not a very difficult but slightly different question. Let's do this quickly. So now you want to do the function of say the int. So you take an input, then you call integer int to convert it the string to an integer. So we want to do that but using recursion. So if you have taken an input, say 0, 1, 2, 3, 4, you want to just return an integer 1, 2, 3, 4, right? So let's get started with it quickly. Question 4. Okay, convert string number to integer using recursion. Okay, so again let's write a function template. Let's call it str2 int. Yes, why not? Okay, I will return something. We'll do something here, and we can take an input like say number equals to 0 1 2 3 4 5, and yeah, return print str2 int of number. Okay, so this is just the basic template. So now this function also, now I think you might be getting the hang of what the base case and the recursive case will be. So the base case here also will be basically if the number is just 0, like empty, right? So if if the string is basically empty, so if s equals to empty, return empty string. Oh no, sorry, not empty string. So if we have like empty string, so what does this mean? This means basically 0, right? Like no number. So you want to return a 0. Or you can also set like if string has only one character, you can also do this len s. So if we assume that at least there will be one number, so if len is equals to 1, then basically return int of s. Okay, or let's just do it, yeah, let's do it like this. Okay. Yeah, so now what will be the recursive case? So the recursive case will be, we have to take one element out, and then we have to convert it to its integer format, and then keep doing the same things for the rest of the string basically. So return say int of s0. Let's do it in one line now. So we are converting the first character to an integer, plus we want to do string to int s1. Okay, so is this okay? Actually, let's do it from the behind. So let's do it from the behind now. You'll understand why after some time. So is this okay? So if we run it, what will we get? Let's run it and see. So we are getting some random numbers, 15. So what is happening? So now one thing you can understand is 15 is like the summation of all these numbers. So we are actually just adding all of the digits here. So that is not helpful. So what we need to do is basically we need to multiply this by 10. So I'll explain why, but if you see that now we are getting the correct answer. So what is happening here is so you're calculating, you're taking out the last digit basically, which is 5, and then basically you are saying that I'll show the computation again. So for say 1, or so let's call it just function of 1 2 3 4 5. So we are taking out the last character. We are saying that equals to 5 plus, and then function of 1 2 3 4, right? But we know that this will be in the tens position, because this is in the units, so tens, units, tens, hundreds position. So we know that this will be multiplied by 10 because we have taken out a digit basically from this number. So basically we have divided the original number by 10. If we divide this number by 10, so basically that means we are removing one digit, then we get this. So that's why we have to, since we are removing a digit, so that is like equivalent to dividing the number by 10. So that's why we need to basically multiply by 10, so that it gets shifted by one decimal, like from units place to tens place it gets shifted. Okay, so this is also again straightforward. So now you may ask that like if I was in the class, you may have asked, like I would have asked, like, so why are we doing this? Why are we not just doing int of the whole number itself? Why are we not just doing int of number? Why are we doing so much? So yeah, so answer is again, in Python you don't really need to do this, but say in other languages there is no inbuilt function directly. No, there is inbuilt function, but you so you need to do something to it's not so straightforward in our languages, and so we are just doing this to understand the concept of recursion, so that so next week we'll have more difficult recursive problems, so that you get an idea about those. So yeah, but yeah, in for this problem in real world, you will not do this to actually convert a string to integer. This is just for practicing recursion. Okay, so again straightforward. So now let's go to, so this one is not so straightforward. So this one is a slightly more challenging problem. So we want to write a recursive function to merge two sorted lists, and the output should also be sorted, obviously. So if you are given two lists which are sorted, you know that 1, 4, 6, 7, 9, this is sorted, like it is in ascending order, and you are given another list 2, 4, 5, 8. So this is another list which is sorted in ascending order. We want to merge these two lists into one single list. Now this is a very important problem in real world that is used in something called merge sort. You may or may not have heard. So you know sorting, right? So sorting, with sorting just means arranging them. So there is a algorithm, there is a method called merge sort, which is known to be very efficient, which is actually used a lot in the real world. Actually not a lot, but quick sort is used in real world, but merge sort is also a very important algorithm that you will learn if you continue with learning computer science data structures and algorithms. So this is like a crucial part of that merge sort algorithm. So this is a very important in the real world problem, but also it's again not very difficult. So I'll just show you. So obviously if you didn't know how to do it, or if they were not sorted in the first place, so if you're given two random lists, what would you do? You would just basically add these two lists, join these two lists, and then you would sort it, right? So but sorting is not a very you can say sorting is a very time consuming thing. So if you just run in your computer, you can see in 1 second it's doing that stuff. But if you that's because you are doing only on a very small array, right? Like 5-10 items only. So if you do with a very large array, like in real world you will not work with only 10 items. So if you want to sort say 1 million items, right? 1 million numbers you want to sort. So in that case sorting is very inefficient, we say. It is not very efficient, it takes a lot of time. So we don't want to do sorting unless we really have to. And so that's why we know that these two lists are already sorted from before. So to join them, we can do some clever hacks to join them without actually having to sort any individual lists. So that is like this algorithm that I'll show you, that is like much more efficient, takes much less time to run. Okay, so let's keep this to the side for a bit and let's take a risk. So I'll just explain the method a bit, what we are trying to do, and then we'll go to the code. So what we are trying to do here is basically we want to compare the first items of the two lists together. Basically we want to check if basically check 1 and 2 basically, and then we want to see which one is smaller, right? So whichever one is smaller, we will take that one first. So we will just do 1. Okay, so return 1. So now since 1 has been computed, so now we want to check between 4 and 2. So check 4 and 2, like the second item from the first list and the first item from the second list. Check on 4 and 2. So now we see that 2 is smaller, so we write down 2 basically, and then we move this from 2 to the next item, which is 4 again. So 4. So now 4 can be you can take either of them. So let's say we take the 4 from the first list. Okay, so we take 4 and then we move on to the next item, which is 6. So we now check 4 and 6, and now we see that this 4 is smaller. So we write down 4 again and we move from 4 here on the second list to 5. So we now check between 5 and 6. So again 5 is smaller. So we write down 5 again and we move on to the next number in the second list, which is 8. So now we check between 6 and 8. Now 6 is smaller. So we write down 6 and then we move on to the next item in the first list, which is 7. So check between 7 and 8. So similarly it will go now 7, 7. Then we'll check between 7 and 8 and 9 and 8 because 9 is the last element. And then we'll do 8 and then finally we have finished one list and like empty, nothing else. So we know that like only one is remaining, so 9 we will just write down. And if there was say another number 10 over here, then we would write 10 again over here. Okay, so this is the basic algorithm. This is also called the merge algorithm. If you search Google with merge, you get this. So it is not very difficult by loops also, but we'll do it with recursion. So we'll just write the function now, merge two sorted lists using recursion. Okay. All right. So let's again do the standard things. Merge, say list 1, L1 and L2. We have two lists, and we'll do some things over here. Returns something, and yeah. So let's us initialize these two lists. List 1 is say 1, 4, 6, 7, 9. Let's also add 10. L2 equals to 2, 4, 5, 8. Okay. And then we just want to print merge L1 and L2. Okay. So this is our standard thing that we have been doing till now. Just we are calling this function. So now we have to basically now we have to understand how to do it basically. So now here understanding the base case is not so simple as before, but it is not that difficult also. Like the examples I showed, if you were paying attention, so at the end, so base case is basically in a recursion, base case is where you want to stop, right? When do you have to stop recursing? So we saw that at the end, what we are doing at the finish, when we finish, we saw that when one list was empty, basically then we know that all the other numbers will come from the other list, right? So that is our base case basically. So we are checking, say if L1, say if not L1, so this means that if L1 is empty, so that means L1 is finished. So whatever numbers remain in the next second list, just send them, right? Return L2, because they are already, you know that individual lists are sorted already. So assume, oh no, again my power went away, but I hope I am audible. I hope I have not lost connection. Can someone please write in the chat or something? Let me check. My net is working. Can someone just confirm if I am audible? Write in the chat or unmute yourself and let me know. Yes. Okay, yeah, thank you. Yeah, there's some issues with the power today. Thankfully the Wi-Fi is working. Okay, so let's go back to the code. Sorry about that. So assume L1 and L2 are sorted. So that is our assumption. So if one of the lists is empty, then we know that we can just return the other list because that is already sorted, right? So we can just add it to the end. And similarly, we can do the same thing for the other list also, if not L2. So if if the second list is empty, then we can just return L1. So we know that if you have to merge between say L1 and say, let's say L2 was just an empty list. So the sorted, like if you merge them, you will obviously get L1, right? This is the merged array. That is basically what we are doing. So if either of the lists are empty, then we are just returning the other list because that is by default sorted. Okay, so this is our base case. So now we want to move on to the recursive case. So how do we find the recursion here? So in recursion also we are checking basically the first items of like normally if you have to do it by iteration, or like how you are doing by hand, so you are just taking the first item from the first list, we are taking the first item from the second list, and then we are just comparing them. So we'll do a similar thing here also. So item 1 is, say, let's do L0, L10, I2 equals to, say, L20. So we're taking the first item from each of the lists, and then we have to compare which of the which one is smaller, right? So if I1 is less than equals to, say, I2, then we have to return something else, return something. So now what is this something that we'll have to find out, right? So obviously we need to, so if the first item is smaller, so we know that we will write that down like we were writing down in the example a while ago. So if the first item, like I1, is smaller, then we know that we need to write it down. So let's, like, in quotes, write it down. I cannot show in the camera right now, but in quotes, let's write down I1. We are basically printing it, I1. And then we have to basically do the same thing with the rest of the two lists, right? So what we are doing in the example, what we are doing is, so once we have a number from the first list, then we'll move, or you can say we'll move our finger to the next item in the list, right? So in this sense, what we are doing is basically we are just skipping ahead L1 to the next items, L2, and L2 will be the same because we have not taken the item from the L2. So what we are doing is we are writing down the first item from list 1, and then since we have already written it down, we are removing it from the list, and we are saying that, okay, so we have already taken this first item, and now we want to do the same thing for the rest of the two arrays, two lists. And so you can understand now the else part will be basically the same thing. Just so if I2 is smaller, then we have to write down I2, and then we have to just keep L1 as it is, and we have to move L1 to like this. So this is our code, and yeah, we can obviously do it in a smaller way also. Like we can remove this and we can write it in a few lines. So you can see that so what might have seemed complicated at first, but it is actually just 2-3 lines of code, right? So let's test it out and see if it works. So yeah, so we can see 1, 2, 4, 4, 5, 6, 7, 8, 9, 10. So our code works. Okay. So this is the merge algorithm. This is a very useful algorithm. Though in real life, unless you are a computer science major, you won't really need to implement it, but it is a very good thing to know because it is used in real world a lot. But okay, so this is the merge algorithm. So any doubts about the code or in general about the algorithm, if you have any questions, ask me. Else we'll move on to the next question. Okay, I hope my internet is working. Yeah, hopefully. Okay, so let's move on to the last question. I think we have just 10 minutes remaining. Okay, so let's move on to the last question. So this is not on recursion. This is just a cipher code. So you have in the lectures, I think you have already done substitution cipher. So here we'll be doing a slightly you can say more secure version. So substitution cipher is really easy to break if you just basically you try out all the combinations of all the like you do plus minus 1, minus 2, minus 3, minus 4 up to minus 26, also up to minus 25. So if you try out all the combinations, you can see obviously one of them will work, and that is your answer. So substitution cipher is not very secure per se. So an improvement to that is a Caesar cipher. So I'll explain what Caesar cipher is, and then we'll code it out quickly. So Caesar cipher is basically given an input string, and so you have two strings. For substitution cipher, you have a input string and a number, right? A number by which you want to shift all the characters by. So here we have a key string. Instead of a number, we have another string basically. And what we want to do is shift each character in input by the character in the corresponding position in the key. So what does this mean? I'll tell you. I'll show with an example. So suppose we have an input of say A, B, C, D, E, F. let's just say, and suppose we have a key called so this is the input, and we have a key. Say this can be any word, but usually it is like not a very long word, like it is smaller than the input, but it can be longer than the input also. Let's say let's just say Python, or Python will be okay. Let's just do this as Python is fun, and let's just say A B C D E. Okay, let's just say this is our key. So in real world, people often use another word as a key, but you can use anything basically. So let's just say the key is basically A B C D E, and our input is like Python is fun or something like this. Okay. So what we have to do, so output will be, so we have to take the first item, which is P, and we have to shift it by basically A. So what does A mean? Because A is the first character of this. So what does A means? You have to basically, it means that A is the first character of the alphabet. So we'll just shift it by 0. Okay. Next we have Y. Y plus B. So B is the like second character, so we'll shift it by say 1, and so on. We'll do T plus, because it's CDF. Well, let's just remove C. Let's just call it something like this, ABDA. Okay, then it makes more sense. So now we'll do T plus D. Basically, T is the third character of the input. We'll do T plus D. So D is the fourth character. So we'll add 3 basically to this, and so on. Then next comes H for Python, and then we have A again. So plus A, which means basically 0. So basically these will become P, this will become Y after, so it becomes Z. So you can do it plus or minus, you can go either way. Let's just say we are doing plus, and then T U V U V X, and then this will remain 0. And then once the key is over, then you start again from the beginning, right? Then O plus A again basically, and then N plus B, and then usually for cipher the spaces are skipped, so we'll just skip the space. We'll just say is I plus D, and then S plus A basically. So again we'll do same thing basically. So this will become again 0 plus 1 plus 3 plus 0. Okay, and then this will become whatever. So I hope it is clear what Caesar cipher is. So if you have any questions, you can ask me about this Caesar cipher itself. Otherwise I'll move to the code. Well, let's just keep this for now. Let's keep the examples. S equals to. Okay. So we'll move to the coding part. So this is not using recursion. So you can do this using recursion also. So that you can take as a homework, as you can say. So what we need to do here is, as you can understand, let's do it by iteration itself. So we'll keep a result string, result, and we'll keep an empty string. And obviously those things are there, like you can convert things to lowercase and stuff. So let's also import, let's import the string class, because so that we can use string dot what's it called, alphabets. Let me check, I forgot. String dot alphabets, or what's it called? Oh, sorry. Import string dot so ASCII letters. Okay, yeah, not alphabets, ASCII letters. Yeah, so let's just say res is an empty string. So we'll iterate over each item in the string, input string, and we'll do some things, and then we'll print the result. Okay. So now let's do this substitution. Okay, so yeah, one more thing is like I mentioned, so spaces you have to ignore, and also if there are some numbers, you ignore the numbers basically. That is part of Caesar cipher. So firstly, you have to check if C is in string dot ASCII letters. If C is in ASCII letters, then you have to basically shift it by that item in the corresponding item in the key, right? So we have to do something basically. We're coming to that. And if it is not in ASCII letters, then you can just add it to res plus equals to C, right? So now we have to find out how do we get the corresponding item from the key, and also you have to remember that we are also like rolling over. So once the key gets over, we are starting again from the start. So how do we do this? So let's keep a counter, like keep an index. So you may know the enumerate function. So what enumerate does is it also counts. So like if you use range function, you only get the index, but if you use enumerate, you get both the index and also as well as the character. Okay, so I will go like 0, 1, 2, 3, 4, 5, 6, and C will be like P, Y, T, H, O, N, and so on and so forth. Okay, so what do we? So now we want to obviously res plus equals to something, right? So what is that something? Let's call it say TMP, temporary. So what is TMP? So TMP will be obviously C plus something. So you have to add some number to C, right? So how do we get that? So to get that, what we do is basically we have to take the ith element from the key I, right? We have to take the ith element from the key, and then we have to see what number is like A. We converted A to 0. We converted B to 1. We converted D to 3, and so on. So for that, what we can do is actually we can again use this string dot ASCII letters. We just want to find the position of dot. Okay, let's bring it to the next line, or let's just decrease the font size a bit. Okay, I hope it's visible. So dot index key. So what we are doing here is basically we are finding out where in the, or let's just substitute this with something smaller, letters. That will be better, I guess. Letters equals to this. Okay, now much better, looks a lot better. Okay, so I just set the string dot ask letters to another variable. So letters dot index, so what does it mean is it will just return you the position of that character in this string basically. So A will become 0, B will become 1, and so on and so forth. Okay, so is this correct? So if we run it, what will we get? We'll get an error. Okay, but not the error that we are expecting. Okay, so yeah, so we cannot just add two numbers like this. So what we have to do is we have to convert this to C to its number. Yeah. So I hope you know what ORD does. ORD basically does is, or we can just do, I guess, yeah, we can also use letters to shift forward. Let's just do that. Letters dot index C. So you want to find C where the character is. We're coming to that position, and we are shifting that position by this amount of value, right? And then here finally, so this TMP will then become a what's it called? index, right? So you have to convert it again to letters TMP. So I hope this part is okay. So we are just taking the index of the original character, we are shifting it by this index, and then we are just converting it back to a character again. So if we run it, we'll get an error. So the error is string index out of range, obviously, because the key is only of 4 letters, so we need to wrap around. So any idea what to do for wrapping around? So it's very simple. So this is where your modulus operator, the percentage operator, which is like basically the remainder operator, comes into help. So we'll just do length of key. So what this does is basically oh sorry, not there, not there. It will be inside the inside this. Let's just say k equals to this. Okay, so what is going on here is, so we are wrapping around I, and the wrapping around is basically based on the what's it called, the key, basically, right? So the length is 4 right now, so after 4 characters are there, it will again start from 0 again, right? So it will come 0, 1, 2, 3, 4, and so on and so forth. Okay, one more problem I see is over here. Let's just convert it to minus. So let's just say that instead of doing plus, we are doing minus. Okay, just the same thing basically. So if we are doing minus, then it becomes a lot easier. Since time is less, I am doing this shortcut. So if you do minus, so now that we can see that we have something. So this is obviously much more harder to decode than your substitution cipher. So because if you don't know the key, then it's very difficult to understand, like get back the original string from So okay, so that is our code. So as a homework, you can try to do this using recursion. But okay, so that's it. So any questions about this program or any other programs that we solved today? Otherwise, I think it's over time. I think yeah, I'll check the chat quickly. Okay, someone is joining now. Okay, the class is ending now. Okay, so more people coming in. Okay, so I'll wait for 2 more minutes. If there are any questions, I'll answer them, and then I'll end the meeting. So I'll stop the recording.